Let's see what Lenz's law then looks like for the case when the wires are moving and the magnetic field is constant in time. So remember first what the magnetic field looks like due to a loop of wire that has a current in it. If you put your fingers in the direction of the current, the thumb will point in the direction of the magnetic field. That's an easy way to remember how to get the direction of the magnetic field. So first let's take this case where the rod is moving to the right. We showed before many times that the force on the negative charges inside the rod will be downwards. You can check it from the QV cross B rule. And so that means the direction of the current will be in which direction? The current will be in this direction, opposite the direction of motion of the charges. So can you predict that this would be the direction of the current if you just use Lenz's law? Remember, what does Lenz's law say? It says first think what happens to the magnitude of the magnetic flux. When the rod moves to the right, the magnetic flux that's going through this loop, is it getting bigger or smaller? It's getting bigger. So what was the direction of the current? How did we get it from Lenz's law? We said that the magnetic field that the induced current wants to produce will be in a direction to prevent the magnetic flux from getting bigger. So this current, if it goes in this direction to the left, that means it goes around this way. What kind of magnetic field would it produce? It'll produce, if you remember the right-hand rule, put your fingers in the direction of the current, then the thumb will point out of the page. So this current would make a magnetic field out of the page, and the magnetic field out of the page would prevent the magnetic flux from increasing. And so that means that this is the right current direction according to Lenz's law. So even though the origin of the reason why Lenz's law works in this case is different than why Lenz's law worked in the previous case, the final result is the same. You can still apply exactly the same argument that we did before. What happens if you reverse the direction of the rod, if you make the rod go to the left? Well, in that case, the magnetic force will be upwards, because V cross B will be downwards, but the charge is negative, so the force will be upwards. If the charges are going upwards, then the current is reversed. It's going this way. Now, if the current is going this way, can you also predict this from Lenz's law? Remember, what did Lenz's law say? Let's see what happens to the magnitude of the magnetic flux. When the rod goes to the left, the magnetic flux through this loop is getting bigger or smaller? It's getting smaller. So the direction of the current wants to be in a direction to produce a magnetic field to prevent it from getting smaller. So what kind of magnetic field would be produced by this induced current that's going around this way? If you put your fingers around this current direction, the thumb will point into the page. And so the magnetic field that's induced is into the page in the same direction as the original magnetic field. So that means it's trying to prevent the magnetic field from getting smaller. So that should be then the correct direction for the induced current. So you can use Lenz's law with exactly the same statement as we did before, but the origin of the reason why it works is different.